This is lap 10, your pre-alignment inspection or your suspension inspection. This is the inspection that I would do if we were going to do an alignment. This is because to do an alignment, you can't have any worn parts. This is also the same inspection that I would do if somebody complained that their car would pull to the left or their steering wheel was crooked or they were getting bad tire wear or they heard this noise when they went over bumps. So this is your general suspension inspection. We divide it up into about 3 different areas. If you look at your lab book, we're looking at wheels and tires and wheel bearings and things of that nature. We're looking at our steering components, and then we're looking at our suspension components. And so in every one of those areas, we look for modifications. And so like I've mentioned to you, aftermarket wheels, a lift kit, a lowering kit, that tends to wear things out faster. And so I always take note of that sort of stuff. And then we'll also take a look for any kind of body damage. And so when you do an alignment, because of the way that an alignment machine works, you mount the heads up to the wheels, or some of them, your modern ones, will mount over the tire itself. And it looks for everything being level. You can use your eyes to figure out whether a car is in alignment or not if it's bad enough. So if I see the tire tucked in at the top, then that's a bad sign. If I see one wheel kicked out to the side, I can also see if a vehicle is sagging. So I can look and see if that vehicle looks like it sits level or not. So trust your eyes in that. It would also be a bad thing. We would look for wheels and tires if we had different size or mismatched tires. So we would not be able to do an alignment on a vehicle like that. So they have to at least have the same size tires on per axle. So they can be staggered where you've got big tires in the back and little skinnies in the front. That's fine, but it can't have one small one like the donut spare on the front and do an alignment. So in looking at our tires, tread wear, we're gonna pay attention to. So if I look at this one, I don't see any issue. If I look at the tread wear, I don't expect you to get a tread depth gauge out, but what I'm talking about is if I have the tread that's burnt out on one edge, like we've talked about before, then that's a problem. If I see chopped up tire, then maybe it's got out of balance tires or a shock or a strut that's no good. Just safety-wise, I look at the condition. So these ones are severely weather cracked. That's a problem for safety, but it's not going to stop us from doing an alignment. Only worn out parts would stop us from doing an alignment. I also look for damage to the wheels and tires. Are any of the tires separated? Things like that. That can cause pulling problems and things that way. So that's the type of stuff we're paying attention to. How does the tread wear look? Do I have separated parts of that tire? So get down and look at the tire. And do you feel any high spots? Do you see any spots where the tread depth is irregular? That's the type of stuff we're looking for there. And then I'm looking for wheel damage. So do I see any damage to the wheels that would that would be an indicator that this car's been in an accident? One of the things that I'll pay attention to is this is the side that goes towards the curb. And so oftentimes the damaged wheels and tires will be on this side. And so I'll pay special attention to the wheels and tires on the right side of the car. These are stock wheels. I don't see any issue there. Steering wise, there's one operation that you would check from the inside of the vehicle. It's very straightforward and simple. The more play you have in the steering wheel, the more likely it is you have worn parts, all right? Because if I turn the steering wheel, first I have to take up all the slack from play and parts before I can actually start moving steering components. And so in that case, the more play you have in the steering wheel, the more likely it is that you have worn parts. And so we pay attention to that as we're pulling the vehicle into the shop. And so all that it entails is grabbing the steering wheel and see if it feels tight. Do I pull it this way and start to turn the wheel? Do I pull it that way just a little bit and start to turn the wheel? It's very simple. Tire pressures, air them up to manufacturer specs, which would be the pressure on the tire placard. One of the things I'll mention is obviously the manufacturer's tire pressure does go out the window if we modify the wheels and tires. Just as a general rule of thumb to kind of get your head wrapped around it, whatever the maximum pressure is of the tire, we're generally 8 or 9 PSI below that. So like tires that say max pressure 44, they're usually at 35. And so you can kind of use that to gauge, like I don't want it at the max, I don't want super low pressure, but when they're modified, put it somewhere reasonable. It's not gonna be all the way up at the max. We'll be, you know, even 6 PSI below what it says is fine with me, but not right at the maximum pressure that that tire would be. So in checking our suspension and steering, we look over your tires, make sure that you don't see any defects in those, weather cracks, different size tires. We're gonna air them up all to the proper pressure. I've got this vehicle previously racked up because checking steering and suspension is pretty quick. I'm gonna get it up to a comfortable height for me, and then I'll lower it back down on the locks. One of the things I want to make you aware of is that when you're doing suspension and steering inspections, if you find as you go through the auto program that you don't like electrical or you don't like engine performance and having to deal with all the computers and sensors and stuff like that, you can make a great living doing suspension and steering work and doing alignments. It's all touch and feel. You can often do tire work and brake work and suspension work, and it's a lot of touch and feel and a lot less technology. And so this is still very much put your hands on and feel what's broke. But literally, when you're checking steering and suspension, I'm going to unload on the steering and suspension and tug and pull. And I'm feeling for any worn parts that move. If everything moves together and is tight, then there's nothing that's worn out. I'm looking for stuff that goes clunk, 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 clunk. And if I don't feel any of that, then it's no problem. I'm going to go around to the other side and do the same thing and just tug and pull. And if everything moves together, then we don't have any issue. As a general rule, if I get movement and there's play that something is worn on this plane, that's generally steering. If I get something that's worn on this plane up and down, then that's generally suspension components. If it moves no matter which direction, you may have worn steering and worn suspension components, or oftentimes it'll be wheel bearings. The trick to determining what's worn is a lot of your steering and suspension components have joints and ball and socket style of joints where things come together, or a bushing. And so I'll put my hands on that stuff. And if I have two joints that come together like this, and I put my hand over both of them, and I feel them move in my hand, then it's worn out. If I grab between the rotor and the control arm, and I feel the knuckle and the control arm, and I feel that move, or I kind of grasp over the ball joint, and I feel that move up and down in my hand, the ball joint's worn out. If I touch the rotor to the knuckle, and I feel for wheel bearing play between those two, because the rotor would mount to the outer part of the hub and the knuckle would be the inner part of the bearing, and if I feel those move in between each other, then you have worn wheel bearings. So it's very straightforward on that stuff. Bushings, I want to warn you about bushings. It's very visual on bushings. Are they split? Are they torn? Are they do you see damage to them, or do they move? And so depending on the bushing, you may see it move. Depending on how worn out it is, you may feel it and see it move. But a lot of times, one of the things I'll look for is if I've got a control arm that's got a bolt, that goes straight through the middle of it, then I want to see that bushing be level against the bolt. If I see it cocked off to one side or crooked on that bolt, that the bushing wraps around in one direction and it's not level across the bolt, then that would be a way to indicate worn bushings. Also, if you see little rubber shards around the bushing, then that's also a bad sign. Be cautious of the bushings where the bolt comes straight up through the bottom and the bushing has to flex. Then those ones wear and tear out often. But suspension and steering inspections, it's tug and pull, and if it's tight, it's tight. I don't need to look too much further. I've gone through and done the demo of IDing components and IDing parts, because you need to, when you find something worn out, you need to be able to know the name of it so that you can even order that part. I've mentioned that on parallelogram steering, the most common components to wear out would be idle arm and pitman arm, and most of the time they flop up and down when they're worn. When you tug side to side on this, then you'll see your idle arm and pitman arm flop up and down when they're worn out. So that's very simply your suspension inspection on that end. On the front end here, we'll move to the back and I'll show you that. So there's not a lot to check on the back end on a solid axle vehicle like this, but one of the things that I want to make you aware of so that you don't get excited is I want you to hear this if I pull on this. So that sound is normal on a drive axle like this, and it has to do with the way it's constructed. And so I wouldn't want you to go and check a suspension design like this and get excited about that and go, oh, well, it's got bad axle bearings or something like that. So the end of the axle has just a horseshoe clip that comes through it, and what we're getting there is in between the two axle ends is a pin. And when I pull out on the axle out here, I'm pulling back and jamming up against that pin, and you're getting a little bit of play because of the way that it's put together. The clip that holds that axle in, that clips to the end of the axle, is inside the differential and carrier there. And while the pin is in place here, the axle can't move far enough in to where that clip can be taken out. It's recessed up in a hole. And so what we get is a little bit of play between the pin and the end of the axle. And so that's what you hear in this. All of these open differentials will do this. It's not something to get excited about. The basic inspection on this is going to be look at your rubber bushings for deterioration and any kinds of physical damage from accidents or things like that. Outside of that, you can spin these and listen to the bearings, see if you hear any noise that you don't like, but outside of that, they're pretty solid. So I want you to have a good clean look of where we're going to place the jack when we check the ball joints. This lower control arm, the ball joint on the bottom of this lower control arm is the load carrying ball joint, and this one is the follower. And so you can see that as this rests with the wheels hanging, because I have it lifted back from the frame, that spring's going to extend out. The shock will stop it from extending further and limit the travel of that spring. But then that's going to pull these two control arms apart and put tension on both ball joints. So where if I went to check them right now, I would not be able to detect a worn out ball joint without unloading it first. And so to unload it, we'll have the tire back on so we can pry against the tire. But I'm going to place the jack on the lower control arm and lift the car off the ground to where I suspend the tire on this side off the ground. And then that will unload the ball joint. Then the weight will compress the spring back, and then both these ball joints will hang out in the air with no tension on them. And then I can pry with a pry bar and see if they're loose. That is going to be the process for these load carrying ball joints, and that's how you can just check the ball joints. One of the things I always remind people of, because nobody taught me this in school, is that while I have this supported by the jack, I can check all the suspension components quickly by just lifting it with a jack from here. Steering components, ball joints, I can pry up and down, but the one thing I cannot check while I have it lifted by this lower control arm is these inner bushings. These inner bushings, if they're wiped out and tore up, then while it's supported by a jack here, I will not know if those are worn out. To know if those are worn out, I have to lift it from the body or the frame in that case. And so that's the only way that I'll be able to check the play in those bushings. So that's gonna be what we're gonna do to check these ball joints. So I wanted to show you that now so that when we get it on the ground and you see it with the jack, you'll know where I'm placing that jack to check these ball joints. So checking the ball joints, I already showed you where we're gonna lift this from. I'm gonna run this jack underneath and lift this lower control arm until I get this vehicle up off of the ground. So I'm going to get the tire up off of the ground, and this is now carrying the weight from the spring to the control arm to the jack to the ground. And so with a pry bar like this, I can pry underneath the tire and then see if the ball joint is worn out and loose, and you'll be able to feel it. Now, one of the things that I want to warn you about is with this pry bar, I never trust a jack by itself without a jack stand. And so to do this, this is exactly how I'll do it, and I wouldn't use a jack stand. But what I'm not going to do is grab my whole hand around this pry bar. I'm just going to grab it like this to pry up and down, or push up and down on it, but I'm not going to wrap my hand around it, because if that jack does fail, I don't want it to pinch my hand to the ground. If I hold it like this and it knocks the jack out of my hand, no big deal. So in doing so, I can just push up and down on this. There's no concern with reaching your hand in here and feeling the ball joint. The worst can happen is the vehicle comes down. I could also come through and reach and feel the bottom ball joint as I do this. You can usually just feel it. You can feel kind of a pump, 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 pump as you pry up and down on these. If you get the jack in just the right spot, it makes it super easy to just kind of go like this and pry up and down. These are tight. Then you flip and you go and do the other side. The reality is when I'm doing this in real life, this is also when I check my steering and suspension. And if it's tight, you're moving on, and this is a really quick job. And then you pull it back to an alignment machine and go for it. So flip it and check the other side. I want to remind you that if this was a strut suspension design, or if the spring was up on the top control arm, then we would check everything by hanging the wheels out in the air. I also will remind you again that I do not know if the inside bushings are worn out while I have it supported with a jack like this, because I'll never get those to move unless that whole jack moves with it. So for alignments, I want to remind you there was 5 angles that we dealt with. We dealt with toe, caster, camber, toe on turns, and SAI. All of those angles, if they get messed up, can cause a car to pull, but only 3 of those will cause tire wear. Toe on turns, and camber cause tire wear. Caster is a directional stability kind of angle, and SAI is an angle that is an engineering angle that we use to tell if cars are bent, and so from a wreck. But caster does not cause tire wear, but it can make a car pull. The vehicle will always pull towards the side with the least positive caster. Camber can make a vehicle pull, toe can make a vehicle pull, but those 2 will cause tire wear, as well as toe on turns from making too many U-turns, right? So that's what we have going there. Suspension inspection, pretty simple. If we're doing this in class, you check all your tire pressures, which I've shown you how to do. That's kind of going through the motions and air them up. On this part of it, checking just for worn parts, and if everything's tight, then it's tight. So I want to show you the Jounce test for checking shocks and struts. What we're looking for out of a good shock or strut is that it can stop the spring from bouncing, and so generally we want to see is 1.5 rebounds. So if I compress it down, then it can come back up, and then it should stop. And so this is a functional test of a shock or a strut. Of course, we can always condemn them if they're leaking the fluid out of them externally, but even if they're not leaking, we can condemn them off of this test. And so we'll go ahead and do this. I'm going to grab a fender cover so that I don't put fingerprints on this. But I'm just going to bounce this up and down and get it moving and see if it stops. So that settles out nice and quick. If I do this side, settles out right away. If I do the back, a little bit excessive, but not bad. So that one's got a little more than 1.5, but ones that are real bad, what you'll see is they just keep bouncing. And some of you guys, it'll make you feel like you're in a boat, but you've seen them. They pull up to a stop sign and they get to a stop and they're just like, So if you get ones like that, then they're bad. Usually where the weight is the ones that wear out first. And so if we're gonna find real bad ones, a lot of times, since this is a front wheel drive vehicle, you would find the ones in the front get a lot more wear and tear. But that's called a jounce test for checking shocks and struts. I got one more to show you for checking for damage. A lot of times with a front end collision, the tire will not be centered in the fender well anymore. And so one of the real quick little okie tricks that I did when I would check out cars for body shops and stuff like that, and even just customers that had pulling problems, is I would check for body damage just with my hand. That if I could fit my hand up to there on this side, then I would come to the back and go, okay, well, I'm, all the way to there on this side, and then you go and check the other side. And so if I check the other side of this car, it feels the same. And that is a real quick check that on cars that have been in an accident, it'll often pull the frame or tweak it one way or the other, and then you won't have the same spacing of that tire in the wheel well anymore. That's a really quick way to pick up on it. And then now the fun part begins of trying to chase it down. And I use the fingers thing again, where I just check finger spacing between a variety of different suspension components and figure out I'm tighter here and than I am on the other side. And a lot of times you can start to pick up on which wheel is out or things like that. So that's that for just checking for vehicle damage. You can look for wrinkled parts in the frame and stuff as well, but that's pretty much the gist of it. Most of that vehicle damage is measurement. I use finger measurements, or you find it visually that you see something that's got the rust popped off of it, or it's bent physically that the other side's not. So that's that. So I want to orient ourselves for the suspension inspection and just ID a few parts. This is a McPherson strut design. You can see the strut up here. That's our coil spring and the body of the strut here. This does support the weight of the vehicle, the strut, because the spring is part of this strut housing, or encased in that strut housing, and so the spring always supports the weight of the vehicle. And since the strut houses the spring, then the strut supports the weight of the vehicle. So this is the load-bearing portion of this suspension design. Upper part of the strut attaches up to the body. The lower part attaches to the knuckle here. And the knuckle supports the bearing where our wheel attaches and brake assembly that you're seeing there. On the bottom end of the knuckle, you can see the bottom of this ball joint down here. So there's our ball joint there, and our control arm with bushings on either end on 2 mounting locations. So that would be our suspension design, McPherson strut with a strut up top and a control arm down below. Then our steering system is a rack and pinion steering system. So you can see the outer tie rod here, and then the inner tie rod is in where this bellows is inside here. That attaches and threads, that inner tie rod threads into the rack. And so the bellows just kind of protects it from dirt and moisture and the elements. Then here in between the inner tie rod and the outer tie rod, there's a lock nut so that the length of these 2 tie rods stays in adjustment for alignment purposes. And that tie rod bolts onto the knuckle. There's the end of our steering arm. The other big bar that you're seeing in here is the sway bar. That attaches back to the body of the vehicle and then out to the suspension so that the suspension reacts appropriately to body roll to keep the tires always planted on the ground during hard turns. Our little sway bar link is coming up right here. One of the things that I would point out as well is the control arm kind of attaches back to a subframe or a stub frame there, and there you can see one of the bolts to the subframe right here. And if any of those bolts are loose, it could let the suspension kind of shift around. We watch the bolts like that. They often get loosened or moved during repairs. If they don't get tight enough, then it can let the suspension shift and move around. But this, so the lower portion of this suspension with this control arm attaches back to a little cradle or stub frame there, or subframe. And so those would be our suspension and steering components on this front wheel drive vehicle. The axle, CV axle comes through, and we see the end of the CV axle there with a nut and a cotter pin. The torquing this nut sets the tension on the bearings that are in this hub, and so we always want to torque those axle nuts to get the proper tension on those bearings. That is your McPherson strut design with rack and pinion steering. On the back end of this vehicle, it's a solid axle, so it's a non-independent or solid axle design. You just see a simple axle tube coming across that has flanges mounted for the knuckle and then our hub assemblies. It's a mono-leaf suspension, so we've got our one single leaf here, leaf spring suspension in the back. And then you can see the shock absorber right here. No sway bar. We've got our track rod running here to keep this axle from being able to shift side to side. So a really simple construction, not an expensive suspension system to design, but effective in keeping the rear axle and tires aligned with the vehicle and pointed straight down the road. Simple mono-leaf spring with shocks in the back. So that's a solid axle suspension design. Some of the other solid axle suspension designs that you'll see would have the drive axle in the back, and you'd see the differential. So this is another suspension design that's a common one. It's called short long arm. And so what you can see from this one, upper control arm here, which is the short one, longer lower control arm. You got the coil spring in between. This little piece of rubber right here, try to put a light on it so you can see it. That little piece of rubber right there is called a bump stop, that if you ever fully compress the spring, then that would touch the frame. If you ever see those like completely blown up, then somebody's kind of abusing their vehicle typically, or sometimes the springs can be broke or sagging. But short long arm, we've got bushings on the back end. There'll be bushings in here, bushings back in here on the back end of this control arm, so 2 mounting points. Then we've got our ball joint out here at the knuckle, so we've got our knuckle in between our 2 control arms, and then right up through the middle of that spring, which is kind of hard to see, is a shock. So the shock runs up the middle of the spring there. We've got our big sway bar running across with little sway bar links, rubber bushings in between here. Then on the other side, same thing. Upper lower control arm spring, shock in between, knuckle, and then sway bar coming over with the sway bar link going from the frame to the lower control arm. Then, so that's our suspension design, is SLA or short long arm. Then our steering design on this is parallelogram. So the parallelogram steering has basically the same parts on each side. It's parallel. And so the steering component on rack and pinion is a steering rack. On this, it's a steering gearbox. So straight through this way is the steering column and then our steering wheel. And so this is our pitman arm that drives all the steering linkage. That's the idler arm on this side. In between is the center link that connects our pitman arm and idler arm, and then our tie rod ends attach from the center link out to the steering arm on the knuckles. So we've got an inner tie rod, an outer tie rod, and then an adjustment sleeve on both sides, inner tie rod, outer tie rod, adjustment sleeve. So this is parallelogram steering, power steering gearbox here, pitman arm, idler arm, center link, and tie rods. And then the suspension design is short long arm or SLA. So this is now a solid axle here in the back, but this one's a drive axle. So this is not, the front with the SLA was an independent suspension design, and this is now a solid axle design, but this is a drive axle. So inside here is a pinion gear and ring gear, which takes the drivetrain and the rotating force and turns it 90 degrees the same direction as the wheels. So our pinion and ring gear inside this differential here, and their differential housing. So solid axle here, leaf springs again. We can see this is now a multi-leaf design. So a multi-layered leaf there on this, and then we've got our shock in the back. And so there'll be bushings up here at the end of this leaf over here. The shock mounts up to the frame up there and then back down to an attachment off of our leaf spring. But very simple leaf spring, shock, solid axle.